Hi everybody, I'm Jodie. I'm the events manager here at BFBi. On behalf of Nijhuis, welcome to our breakfast briefing webinar on implementing water and energy recovery from site effluent. You've been automatically muted and your video turned off to keep feedback to a minimum. The webinar is being recorded. This will go onto our YouTube channel and it will get pushed down socials as well, for anyone that wants to refer back. We do find that these sessions are better when they're all more interactive. So Andy will do a short Q&A at the end of the webinar. So do post your questions in the chat and I'll make sure they're fed through at the end of the presentation. So thank you all for logging in this morning, and I'm going to hand over to our presenter, Andy from Nijhuis.
Thanks for the introduction, Jodie, as always. Much appreciated. Also thanks to everyone for joining this breakfast session. I'm sure there's nothing more you'd want to do at this time in the morning than learn a little bit more about wastewater and how we can recover water and energy from that value stream. So a little bit about me. I live in Sheffield and I enjoy clinging to rocks in the Peak District, hanging about with my 3-year-old son. And professionally, my passion is looking at clever ways in which we can generate value from wastewater, whether optimizing existing operations or looking at interesting design and build technologies to recover energy and water that can be reused. And ultimately, that's what we're here to talk about today. It's water and energy recovery from wastewater from an industrial site. And we're going to focus on, we've got a few case studies in regards to the brewing and distilling sector. So what are we going to do today? Recovering water and energy from wastewater. What is it? What's the concept and what is wastewater? What's its constituents? Why would we consider doing it? How do we do it? And we're going to look at some business case options in terms of looking at the potential benefits from an OPEX point of view, and also the costs from an OPEX point of view, as well as what the potential return on investment might be for sites at different scales in these two industry sectors. And then we're going to, if I don't completely run over, hopefully there'll be some time at the end for some questions. So, water and energy recovery from wastewater. What are we really talking about here? We're talking about taking wastewater from a brewery or a distillery or industrial process and taking the energy that is bound within that wastewater in terms of its organic constituents, and also removing all other contaminants and pollutants to the point where it can be reused. Ultimately getting from a dirty wastewater that we see in this lovely jar on the left to the point where, you'd almost be happy drinking it. And in some cases, even in the UK, that this is now a common occurrence, that we are getting to the point where we are directly reusing wastewater for contact with product and to actually go into product. So we're basically taking wastewater and then we're recovering clean water, energy, saving carbon, and also some OPEX costs along the way as well. So a really exciting subject in the demands of the industry that we see now. So wastewater, what is it? What's in there? So an extremely high proportion of water, that's for sure. And then we have the organic load. So the inorganic and organic pollutant constituents within that wastewater. This is measured and referred to in the industry as COD, which abbreviates as chemical oxygen demand. But the important thing is this is how we measure the complete mass of organic and inorganic pollutants in a wastewater, referred to as COD. So it's important that we understand that, because when it comes to the business case, to understand the difference in scales, it's important to understand that value. So COD is the complete mass of inorganic and organic pollutants in your wastewater. And then we have solids. So this is particulate solid matter. Um, this could be examples like, sand, sludge in brewing and distilling. This could be remnants left over from the steeping brewing process, wheat, barley, husks. This is in the realm of wastewater design and engineering. This is referred to as total suspended solids, dissolved solids. You might also hear the terms dry solids and volatile solids being mentioned. But this is essentially the total solids content within your wastewater. Then another major constituent is nitrogen and phosphorus, or macronutrients. And this is ultimately the key element that we want to stop getting into our waterways to ensure that we do not result in algal blooms and contributing to fish death. You'll hear the Environment Agency having lots of KPIs around that. And then we also have micronutrients, trace elements in the form of metals, microplastics, also within our wastewater that we need to be aware of. So we've touched on there about fundamentally what is wastewater energy and water and energy recovery from wastewater. Wastewater, what is it? What are the main constituents? And now we're kind of talking on the why. Ultimately, why would we want to go to the effort to recover energy and water from our wastewater? Environmental is a big one here. Ultimately, we all want to improve the conditions in the environment. We all want to reduce our own impact and the impacts of our business and others around us. So, this gives us a great opportunity to reduce the amount of energy that we'll be utilizing from other sources by recovering energy from that wastewater. It gives us a great opportunity to reduce the water consumption of our site. And this is a real serious issue at the moment. I can't believe it myself, but it's getting to the point now where I'm actually in Aviemore up in Scotland. And this year, the distilleries have really suffered with a drought. They've had so little waterfall that they've had to delay production of their lovely product, whiskey. So we're getting to the point now in the UK where even in Scotland, we're suffering from major drought issues, having major impacts on the industrial sector. So this is a really big positive driver for recovering water from our wastewater stream. And then we've always got to keep the finance manager happy. And with this does come some benefits in terms of if we can recover the energy from that wastewater, which reduces our COD levels, also, then that comes in two factors. We can reduce the costs for energy usage on site by generating our own sustainable energy source on site, but then we're also reducing the level of pollutants that if you've got a sewer connection, for example, you're then reducing the amount of the pounds and the pence that you spend to discharge that wastewater to sewer on the organic load content. So there's some benefits there as well. Also, if we're reducing water, that means we're reducing the pounds per meter cubed that's coming into our site, and we're also reducing the volumetric discharge costs if we have a sewer connection as well. So some great opportunities to improve the OPEX associated with our site. And operationally, and this kind of touches on the first point, it's becoming more and more common now that the Environment Agency is coming to industrial sites now, not only at the highest level, but even the medium at small sites, and saying, you can not extract any more water, or you even in some cases you need to reduce the amount of water that you're extracting. So implementing energy and water recovery is becoming a license to operate in a lot of cases now. It's a very common thing that we're seeing. And also, and most importantly, it's sustainably. We all have a responsibility to reduce the impact on the environment, and we all have net zero targets for our businesses. But ultimately, this is also something that we all want to do on a personal level as well. So this is really part of changing the culture around seeing sustainability as a cost, but actually seeing it as a must. And I think that's the culture shift that we need to focus on. So how do we do it? How do we recover energy and water from your wastewater stream? Ultimately, we have a number of different technologies that are responsible for removing different elements from your wastewater to the point that we can get to the point where we can actually recover energy from that wastewater and also reuse that water on site. So I've given sort of a high level overview here, depending on your site, depending on your specific situation and what you want to do. Some of these technologies may be swapped out for others, depending on the exact need. A few examples might be that you might wanting to get to potable water quality, like producing drinking water. So you may have some additional sanitization steps on the final treatment. But what I'm going to go through here is sort of the workhorses, commonly industry best practice technologies to recover energy and water from your wastewater. I haven't shown any tanks on here because I didn't have any room on the screen. But ultimately, the first step is screening. So you will have I've selected a drum screen here, but this is ultimately to remove the heavy solid fraction from your wastewater, because we want to make sure that we haven't got any nuts and bolts getting onto the downstream assets and causing damage, and we want to remove as much solids load as possible that can be recovered for something like animal feed or a high value stream. So we've now removed the solid fraction. Then we're on to I've selected a DAF unit here. This is responsible for removing the light solid fraction of the wastewater. And we are including some chemicals here where we are essentially coagulating, flocculating. This basically means binding the solids together to the point where we can remove that solid fraction before we going on to a biological treatment process, because we want to reduce the amount of solids loading on these downstream biological treatment processes to make sure they are efficient in terms of energy and treatment efficiency. The next step is anaerobic digestion. So this is where we are recovering energy from our wastewater. So we're utilizing anaerobic bacteria, which converts or consumes our all organic pollutants, or COD, into methane, which can then be burnt as a offset for natural gas in a CHP process to produce energy. So that's how we produce our energy. Then we've got our residual COD left over, and we need to keep cleaning the effluent until the point where we can utilize a set of membranes at a very small pore size to recover that wastewater. So we've had our anaerobic treatment to recover the energy. Now we're polishing up the remaining effluent to get to the point where utilizing aerobic bacteria, which consume oxygen to convert COD to consume COD, and then improve the quality of our wastewater to the point that it can be treated via a set of membrane technologies, typically ultrafiltration, which is part of the MBR, and reverse osmosis, which can then essentially a very, very fine filter, which can then get it to a almost potable water quality standard. And the main steps that you need to get to that point is a major sanitization step, which could be UV ultraviolet, chlorine dosing, ozone, depending on your site-specific requirements. And then we also, out of these processes, we have a lot of sludge to manage. So we also have a dewatering process to take the water out of our sludge to keep our disposal costs to a minimum. This could be a screw press, a centrifuge, to manage that sludge process. So these are the high-level technology treatment steps that we would employ to recover energy and water from our wastewater. So, yeah, we've talked about the concept. Why do we do it? How do we do it? And then what I wanted to do was share some business cases, ultimately for brewing and distilling. Depends on how much time we've got left. And yeah, we'll see how far we go, whether we can get through all of them. But what I've put together is a table which for the brewing sector, which basically highlights on the left there your annual production capacity. So you've got breweries at different scales, highlights the typical wastewater generated from a site of that scale, the COD, in terms of tons per day. The top 3 rows are actually in kilograms. But yes, the top 4 rows are actually in kilograms. It's the final row is only in tons, the 10 tons per day. And we've also highlighting the potential water that can be recovered from these sites. So I guess the key thing that you can notice is that for different production levels, one, yes, they produce different levels of wastewater hydraulically, but also from a load point of view. And you can typically recover between, I've been conservative there, but you can recover up to 75% of your wastewater. But overall, holistically, as complete wastewater you produce, it's normally between 60 to 75% of what's coming in. That doesn't really change depending on the scale of production. And the difference in the actual design that you might employ at those different scales is that anaerobic digestion only really comes into its own in terms of a financially viable option at a slightly larger scale. So you'll notice for the first production capacity of 50,000 hectolitres, I haven't incorporated anaerobic digestion within that. I've only included the aerobic biological treatment. And that then goes on to highlight the pounds and the pence. So for a brewery of these scales, what is the potential benefits in terms of the potable water savings, assuming that we are taking potable water and paying for that from a water utility, and we're paying to discharge that water to watercourse as well. So you can see there that there is some sizable OPEX savings potential to recover that water. And also, as we are removing that COD, that massive organic pollutants that we're discharging to sewer, if we have a sewer connection, there's also some desirable OPEX savings associated with that as well. And then also, if we're incorporating anaerobic digestion, we have sufficient load and we're a brewery of a sufficient scale, then we also have that benefit in terms of energy and heat that's recovered to offset our existing power costs. Yes, we have to include OPEX costs to offset that, which is going to be power, sludge disposal, chemical use, additional operational maintenance costs. And what you'll see there is that how does that affect the ROI if we're looking at the breweries of production of different production scale? Well, if you're looking at aerobic treatment alone, because you have a relatively high OPEX, and then the ROI does, and you don't have the benefits associated with energy and heat recovery, then you do have a much longer ROI. And the more COD load that you've got, and the higher, which essentially it means that you can recover more energy. That essentially means that you're improving that payback because you're producing more power and heat that can be recovered to help that business case. There is an economy of scale with wastewater treatment in terms of improving that ROI. But also we have to balance that sometimes these technologies are employed because there is a license to operate. For example, a river water, a water abstraction challenge, for example. And capex investments for these scales can range everything from, if we're going from the top to the bottom of the tables, can range from anything from £1 to £7 million. It all depends on the site specific requirements, material specifications, and footprint available. So that's really the summary of the brewery business cases that I put together. And the key takeaways are that the more COD load you've got, the better the business case and the quicker the return. And the anaerobic digestion's typically more favourable for your sites with a higher production value. But as you can see, some interesting OPEX cost savings. Also, I do just about have time to go through the distillery business case models that I've also put together. The difference between brewing and distilling is that they have a much higher COD concentration or organic load per volumetric unit. Basically, it's highly concentrated in the wastewater, the COD, compared to brewing. And this has a benefit in two ways. That you ultimately you don't have to size your equipment hydraulically as large, and you have a higher COD loading to improve that business case. The potential for water recovery, 60 to 70%, 75% remains the same, and typically anaerobic digestion can be employed for smaller sites because the COD load is COD concentration is a lot higher than in the brewing sector. So ultimately, what this means for the business case is that because we have additional COD load, it's more concentrated. We've got more fuel to produce a sustainable energy source, which has additional OPEX benefits. Then the return on investment can be a lot higher. But it's also important to note for the distilling sector that typically, although I've shown here that the potable water savings and sewage discharge savings, it's quite common for distilleries to not be paying £1 per metre cube for the water that they take in, and typically they are discharging to a watercourse or a long sea outfall. So typically the business case has to be built on a license to operate, sustainability, just to the nature of the location of these sites and the specific water balance. But because they do have a high COD load, it does help the business case for anaerobic digestion dramatically. And anaerobic digestion can be employed for a site with a much lower wastewater volume, just because of that higher COD concentration. I've also highlighted sort of a high-level carbon assessment for distilleries of different sizes in employing water, recovering sustainable energy from your wastewater, utilizing a CHP. And I deal in wastewater, not carbon. So these figures are estimated. And if you'd like to know more on these figures, then please email me at the end in terms of how these were calculated. I can share a bit more detail around these. But ultimately, because we're not utilizing as much water, that water requires carbon to get to the site in terms of its production and treatment. And also we're producing a sustainable energy source to offset fossil fuel derived energy sources, if that is the situation on site. So there's some great benefits in terms of carbon there as well. So all in all, some really interesting total carbon savings per year associated with distilleries of different sizes. And this doesn't even include things like reducing the amount of effluent that's being tankered off site and the associated carbon with that. So, recovering energy and water from wastewater, also a great opportunity to reduce some of those scope 1, 2, and 3 emissions. So yeah, we're doing all right for time so far. I think I've got 5 minutes left. What are the final points? Ultimately, recovering energy and water from your wastewater has some really amazing benefits in terms of reducing our environmental impact and sustainable management of our site resources. And we really need to get to a point where we have a culture similar to health and safety when it comes to sustainability, where it's not a nice to have, but it's a must. So yeah, I think we all have that responsibility to make sure that we are recovering as much water and energy from our site's water balance as possible. So, and it has some big benefits for us personally, but also in terms of the business as well, in terms of strengthening the environmental position and credentials of our sites. But what we are also commonly seeing in the UK industrial sector is that it's a must because of water scarcity and our abstraction limits being reduced, but also our discharge consents being tightened to the point where we have to employ additional technologies to reduce the pollutant that we are putting into our watercourse and sewers. So although there's a big sustainability driver, also it's important that this is actually turning into a license to operate for our site. And this is really a standard industry best practice that we should be employing when looking at the future of an existing site, but also the expansion of our site or when we're building a new site. And yes, there are OPEX costs that are attractive, and there's definitely a net benefit based on the OPEX, but there can be long return on investments. So I guess that's what we've got to kind of make that culture shift to embrace the return on investment for a slightly longer term, but ultimately we're doing this for the right reasons, which is to improve the sustainability and license to operate for our site. I've got one more slide after this, and these slides will be shared afterwards. I just want to stop for a minute or so. I've got my contact details at the end there. Please feel free to reach out if you'd like to get a better understanding of what you might be able to achieve with your site or project. As I say, it would be great to work with you and start to look at how we can improve the design situation of your current site to how we can get the most value from your wastewater in terms of recovering energy and water. As I say, my email address and number is there. Please don't hesitate to give me a call after this if you've got any questions and like to discuss further for your particular situation. And then a final note on on who I work for. I work for Nijhuis Industries. We're a global business, but we have a large footprint in the UK. 185 design and build references on process water and wastewater treatment, and 30 O&M partnerships where we take complete O&M responsibility of not just our own technology, but also other sites to make sure that you are compliant and utilising your wastewater in the right way. And Nijhuis Industries supports the complete life cycle in terms of wastewater and process water on your site, in terms of laboratory scale feasibility testing to look at the optioneering and best available technologies, We can then support the front-end engineering design with a dedicated EPC team, 75 full-time equivalent, based in the UK. We manufacture the technologies by a number of manufacturing centres in Europe, and we have a complete technology portfolio, meaning that we can select the technology that's best for the application, not just to suit the core technology that we'd like to, that we have a bias towards. That's a big benefit of working with Nijhuis. And then because we've got that dedicated EPC team, and that's the timer gone off. And we've got that dedicated EPC team to deliver that project. We also have rental assets in process water and effluent treatment to support outages, temporary systems, or if OPEX cost model is preferred. And then, as I say, we have a complete asset management team, sort of 300 full-time equivalent across the UK, which have 24-hour, 365 O&M responsibility for process water and effluent treatment plant assets at industrial scale, and a service and maintenance team to support that, to support any ad hoc maintenance. And yeah, that's all I wanted to go through today. As I say, welcome to receive any questions now, but also I'll just put my contact details up there again. If you want to talk about this topic, or anything in regards to improving the processed water and wastewater situation on site, please do not hesitate to reach out, and thanks for joining the session.
Thank you, Andy. We have got a question in the chat for you as well, which is good to kick that off. Thank you, Eric. What breweries or distilleries have you installed effluent treatment plants for using treated effluent to make beer and spirits from?
Is that a question around where have we installed technology to the point where a brewery has used that water for a product?
I assume so. Eric, did you want to elaborate on your question? Yes, he said yes.
Okay. Yeah, no, that's great. That's great. As I say, in Nijhuis, we don't have a reference specifically in the UK, just because I'm biased towards the UK, as that's the region that I look after. We may have in Europe. I guess there's another way in which I can answer that question. The one large, very popular reference in Nijhuis that I do know about is within the poultry sector. So this is a very large scale poultry processing facility. And you can imagine how much worse poultry wastewater is compared to brewery wastewater. And we have a very large scale reference where we produce drinking water quality that comes in direct reuse with the product. And that is certified as EU drinking water quality and is used for all potable water uses on site. So yes, we can do it. But I definitely know of other references and technology providers as well. There's definitely references in the brewing sector where this is done. I think Heineken or Carlsberg in Belgium definitely have a reference there as well. So if it's a question around can it be done? Is it done? Yes, definitely. Yeah. And there are industry references globally for this.
Thank
Is
you,
there a
Andy.
reference in the UK? I don't think so. But do we need to change that? Yes. I mean, we're actually working on a number of projects where, at the moment, which are planned for construction over the next year or two, where this will be done. So, yeah, it's UK is a bit behind the curve on reusing wastewater to the point where it can be used as a blending with the borehole for use within your brewery. But as I say, we are catching up.
So we've got a question. It says, hi, I work for a brewery with an AD, and we are looking to at increasing our COD loading on our AD by beginning to dewater our hops with a decanter centrifuge, then putting the liquid steam through the WWTP. However, we are unsure on how to know that this is an appropriate amount of COD solids to put through our AD without overloading it or drastically changing process dynamics.
Okay, yeah, that's ultimately how we typically approach something like that is in the form of a engineering study or process improvement plan, where first you've got to benchmark your existing design, look at the reactor capacity, look at the current treatment levels in terms of organic loading rates and COD removal efficiency that you've got currently across the reactor, and then design, well, basically understand what is the remaining capacity within that reactor and can it take that additional load. Um, and then there's a number of ways in which you can look to increase the capacity of an existing reactor by optimizing the temperature, reducing the solids loading on that reactor to increase capacity. Look at the potential for increasing the biomass volume within that reactor. I say we operate and maintain 13 anaerobic digestion processes, majority of those breweries. And we're very used to needing to increase the capacity of those sites without major capex investment because that's the need of the industry. So yeah, if you'd like to investigate that one more, be happy to work that one through with me. But I've given you a few examples there and a start process, but we have sort of a structured staged process to basically benchmark the existing design and then come up with different options in terms of how you make sure that you can, when you increase that COD load on the reactor, you've got complete peace of mind that the reactor is going to cope with that additional load.
I think that's it, Andy. I think those questions were a great finish to the webinar. So thank you very much for hosting us today. And thank you for everyone joining. As Andy said, his contact details are there. Shortly after this, hopefully today, or if not, by the end of the week, we will share the slides and this recording and also a quick survey as well, so you can give your feedback on the webinar. But I can share Andy's contact details in that email as well. So thank you, everybody, and we hope you have a great day.